Hello student, in class 9 CBSE board we have to study about the chapter motion. So in this video we will study about this chapter in detailed way and we also solve few questions based on this chapter. So first we have to know what we have to study in this chapter. First topic is distance and displacement. Then we have to study about the speed, graphs, acceleration and the circular motion. Okay, so let's start this chapter. If we consider any object, so this object can stay in two positions. One could be at rest or it could be in the motion. Means around us anything which is present can exist two states. One is at rest and second is in motion. So we can write it as position of the object could be at rest or in motion. So how we will define a body is at rest? So when a body is at rest, it means that its position is not changing with respect to time. If we have a body here and this body is not moving with respect to time, means suppose when time is 0 second, that time it was at rest. So x is 0. When time becomes 2 second, then x is 0. Time becomes 4 second, x remain 0. Means the position of the body is not changing even the time is changing. Okay, so then the position is at rest. So rest is defined as when the position of a body is not changing with respect to time. Then the body is said to be at rest. And how we can define motion? Motion is defined as when the position of a body changes with respect to time. If we consider example, here we take a car. So this car initially x was 0 when time was 0. But after a certain time, this car will move and change the position with respect to time. So if we consider three different position of the car. So here x could be 2 meter when x is 1 second. Here x is 4 meter when t is equal to 2 seconds. So what you notice it here? With respect to time, position of the car is also changing. So when you are studying, that time your position is at rest. But when you are playing some game like badminton, cricket, that time you are in a motion because your position is changing with respect to time. Now we will study about the distance and displacement. Distance is defined as when a body covered a path, the length of the path is considered as distance. Let's take an example. Here is a point A and here is a point B. If A has to go to point B, so whatever the path it covers, the total length of the path is called as distance. Let's take example. Here it covers one path. It first goes to C and then B. So here AC if we consider 3 kilometer and BC is 2 kilometer. So what is the distance here? Distance of AB will be considered as 3 kilometer plus 2 kilometer equal to 5 kilometer. If a person will take different path, suppose person want to go this way first, then here, and then this way. So we can consider this is D and this is E. So AD is, let's take 2 kilometer. D is also 2 kilometer and EB is 2 kilometer. So here, when the distance is covered with respect to A to C and then C to B, that time it is 5 kilometer. And when the distance is considered via A to D, then D to E, then E to B, then it comes 2 plus 2 plus 2, which is equal to 6 kilometer. So you see, if we have to go from A to B, there are many different paths are there. And which path you choose, according to that, your magnitude of the distance will vary. So here, distance doesn't depend upon the direction. So we can say that distance is a scalar quantity. What is the meaning of a scalar quantity? A scalar quantity are those physical quantities which has only magnitude but no direction. Let's take an example for this better understanding. Here is a person at position A. This person reaches to position B and the distance between AB is 4 kilometer. And after reaching, it again come back to the original position A. So what is the total distance? So what is the scenario here? A person moves from A to B and then return back B to A. So in this case, distance is equal to distance of AB plus distance of BA. It is equal to 4 kilometer plus 4 kilometer, which is 8 kilometers. So here, distance doesn't depend upon direction because in both the direction, whether it is going from A to B or B to A, direction is changing. But we will not consider the direction. So that's why here direction is not changed, means distance is always added, it never subtracted. This is the second point of the distance. Third, distance is always positive because distance doesn't depend upon direction. So whenever we cover any path, it will be always added. So that's why distance is always positive. You just check the previous example where distance is coming positive. Next is distance SI unit is meter. So the length has many units, centimeter, kilometer, millimeter, but SI unit is the standard unit which is always considered as meter. So these are the few points of the distance. Now if we understand about the displacement, so then we can summarize the difference between distance and displacement. Displacement is defined as a shortest path covered by a body. It's called as displacement. And the shortest path is always depend upon initial and final position. So we can write it. It always depends upon the initial and final position of a body. So if we take a previous example where we consider 2 point A and B. So here the shortest path is always a straight line. It means that if we have a 2 point A and B and its shortest path is join the point A and B. So this is the shortest path, and shortest path is always considered as displacement. So if we have two paths, one is shortest path and another is A to C and then C to B. So here displacement will be 5 kilometer. By using the Pythagoras theorem, we can find the shortest distance in this question. So how it is 5 kilometer? We know that AB square is equal to AC square plus CB square. So AB square is equal to 4 square plus 3 square. So AB square is equal to 16 plus 9. AB is equal to 25. So here we get AB as 5 kilometer. So if a person covers a distance A to C and then C to B, what is the total distance here? It will become 7 kilometer. But displacement is 5 kilometer. So one point we can note it down here. Displacement is always less than or equal to distance. So here, when distance is equal to displacement, when both are moving a straight path, means if you have a example where this is a straight road and in this road one car moves straight. So here from point A to point B, when the car will reach, it will cover equal distance and equal displacement. So in this case, distance is equal to displacement. Rest all the cases, distance is greater than displacement. Next point, we can note it down. Displacement is a vector quantity. Vector quantity means a physical quantity having both magnitude as well as direction. Let's take example to understand the vector quantity. If a person starts from A, moves to B, distance covered is 10 kilometer, and then again it comes back. So that time it will be minus 10 kilometer. Why? Because displacement depends upon the direction. So when the direction is changing, so its sign will also change. Because direction we represent with a plus or minus sign. Suppose a body moves towards north, so we can consider it as positive. But when the body start moving towards the south, then we consider it as a negative. So same thing here, when a person moves towards the right, so that time we consider it as a positive. But when the person starts moving towards the left, we consider that negative. So in this case, displacement is equal to plus 10 kilometer minus 10 kilometer. So if you solve it, it is coming as 0 kilometer. But what about the distance? Distance will consider as 20 kilometer because distance doesn't depend upon direction. I hope you understood this part completely. Next point is displacement can be positive, negative, or zero. Zero example we saw previous example. Now negative we will understand. So here is our point A, this is B, and here it is a point C. If any person moves from A to B, what happened? First, it moves from A to B, then B to C, and after that, it moves from C to D. Let's make a D here. So A to B distance we can consider 10 kilometer. B to C is considered 5 kilometer, and C to D considered 10 kilometer. So if a body moves from A to B, so then it will become plus 10 kilometer. When a person moves from B to C, it becomes minus 5 kilometer because direction is changing. And when a person moves from C to D, it is minus 10 kilometer. If we have to find the displacement from A to D, then it will be equal to minus 5 kilometer. How it is minus 5 kilometer? See, if body moves from A to B, that time it is plus 10 kilometer. Then body moves from B to C, it becomes minus 5 kilometer. And after that B to D, which is minus 10 kilometer. So when you will solve, it will come minus 5 kilometer. You can also understand this question with the concept of initial and final position. Your initial position is A and your final position is D. So A and D distance will be minus 5 kilometer. So here we understand that displacement could be positive, negative or 0. Next point is displacement. SI unit is meter, which is same as distance. Now I will summarize the difference between distance and displacement. You have to remember that summary, so in exam you can write it properly. So this is the summary and the difference between distance and displacement. You will remember these points for better understanding. Now if you are confident with this module, now try few questions based on it. These are the 3 questions for your practice. You will solve it and write your answer in the comment box. Now we will study about the next module, which is speed and velocity. The speed is defined as when a body travels a distance with respect to time. So in formula we can write it, speed is equal to distance upon time. So speed can be written as distance upon time. So here, if we have to derive the SI unit of speed, so what we can write? Distance is represented as meter and the time is represented as second. So speed SI unit is meter per second. It is also written as ms minus 1. So what happens if we have a path and here is a car on this road? So if this car will move, so what will happen? Distance will change. And when it is moving, so definitely time is also changing. So when we take a relation between distance and time, that is called as speed. So here at position A, the body was at rest. That time we can consider 0. At point B, X suppose it is 10 meter and time is 1 second. Now at this point C, distance is 20 meter and time taken is 2 seconds. So what is the distance of AB? Distance of AB is equal to 10 meter. And how much time taken by AB? It is 1 second. So if we have to find the speed between AB, then it is equal to distance upon time, which is 10 by 1 meter per second. So we will get 10 meter per second. Similarly, if we have to find the speed between AC, then it will become 20 by 2 meter per second, which is 10 meter per second. So by this method, we can find the speed. Speed is a scalar quantity. It means that it doesn't depend upon direction. If a body moves from A to B with a speed of 5 meter per second and come back from B to A with a speed of 10 meter per second. So here in both the cases, speed will be positive because speed doesn't depend upon direction, whether it is moving towards the right or left. But always remember one thing, students generally do this mistake. When they have to find the total speed, they start adding. Total speed is equal to 5 meter per second and 10 meter per second, which is equal to 15 meter per second. It is wrong. What we can do? We always has to stick with our formula. Speed formula is total distance by total time. If we have to find total speed, then we have to consider total distance divided by total time. So in this question, if we have to find total speed from A to B and then B to A, so what we will do first? We have to find the total distance. So here total distance is from A to B, we consider the distance as D, and B to A is also same as distance D, because whatever the distance it covers, same distance it covers to return back. So here total distance is equal to D plus D, which is equal to 2D. Now come to the time. When the body moves from A to B, that we can consider as time of AB as T1, and when it is coming back from B to A, then it is considered as T2. So total time is equal to T1 plus T2. So how we'll find the total time T1 and T2? So we know that speed is equal to distance by time. So when a body moves from A to B, that time speed is equal to 5 meter per second. So we write 5 meter per second. Distance is D and time is T1. So T1 is equal to D by 5. Similarly, when a body moves from B to A, then in this case what happened? Speed is 10 meter per second, distance is same as D, and time is T2. So T2 is equal to D by 10. So these two relations we got it, T1 and T2. So if we substitute T1 and T2 value in our total time, so we can write it as D by 5 plus D by 10. So T is equal to 2D plus D, which is 3D by 10. So total time we got it, and total distance we have it. So what is the total speed? It is equal to 2D, which is the total distance, divided by 3D by 10, which is the total time. So here speed you will get it as 20 by 3, 6.66 meter per second. So this is the total speed. Total speed you can also consider at average speed. I will explain you later, but just a information I explained you here. So I hope you understood this part properly. Now the next point in a speed is, the speed is always positive. It is same as the distance. Next point is speed always depends upon the path. As the distance, it always depends upon the path. So same speed also depends upon the path. Now we will study about the average speed. What is the meaning of average speed? So here, suppose what happened if any person rides a car, and this person start from point A and it has to reach to point B. So in this path A to B, might be there could be some disturbance due to jam, or some roads were not good, or some humps were present on the road. So due to that, what happened from A to B, the speed of the car changes. Means it's not moving with a constant speed, it will change. So average speed defines how much distance it covered in the time interval. It means that if a body starts from x is equal to 0 and reaches x is equal to 10 meter, if the initial time is 0 and the final time taken is 10 seconds. So what is the average speed? Average speed defines as the total distance covered by a body in a given time interval. So here, if we have to find the average speed, we can write it average speed is equal to final distance. Suppose we represent this one as initial and this is final, minus initial distance divided by final time minus initial time. It can be written as x2 minus x1 divided by t2 minus t1, or it is also written as delta x by delta t. Delta represents the change. So suppose you consider x as 0, but if you consider x as somewhere here, this you can consider as 4 meter. So if you consider from A to B, then it has a different average. But if you consider from C to B, then it has a different average. Why? Because distance is changing and time is also changing. Okay. So with the help of this formula, average speed, we can find the values in between any two position of the body. Next is instantaneous speed. How we can understand instantaneous speed? Let's take example. So here, as you see, this is the three different position of a car. So let us assume when the car is at position A, that time was 3 p.m. So that time speed of the car was 40 kilometer per hour. At B, this is the point for A. At B, the time was 3:10 p.m. That time the speed of the car was 50 kilometer per hour. And again 3:30, the car of the speed was 30 kilometer per hour. So you see, at a specific time, there's a specific speed of the car is there. Means at 3 p.m. the speed of the car was 40 kilometer per hour. Means you are talking about at a specific time. This is not an average speed. It is the speed of a car at a particular instant of time. If we go to 3:10 p.m., it becomes 50 kilometer per hour. If you go 3:30 p.m., it becomes 30 kilometer per hour. Means at a specific time, there is a specific speed of the car. This is called as instantaneous speed. We can define as the speed of a car at a instant of time. This is not a average speed. It's just a speed at a particular time interval. I hope you understood this part properly. Formula is same. Formula is not changing. Its formula is same as the distance upon time. Now we will study about the velocity. Velocity is defined as displacement of a body with respect to time. Speed was distance covered by a body with respect to time, but velocity is displacement of a body with respect to time. So here velocity can be written as displacement upon time. Displacement we already studied. So what is the SI unit of velocity? It is equal to meter per second. Because displacement SI unit is meter and time is second. It can be written as small m divided by s, or ms minus 1. Velocity of vector quantity. Because displacement depends upon direction, so displacement is a vector quantity, and when the velocity is displacement by time, it means that velocity should follow the direction. So it is also a vector quantity. So how we can understand this? If we have, so here is a car A and this is the position here B. So what happened if this is moving with a velocity of 10 meter per second and this is moving with a velocity of 5 meter per second, but both has different direction. So with respect to A, we consider plus 10 meter per second, and with respect to B, we consider minus 5 meter per second. So it represents that velocity is a vector quantity. Now, velocity could be positive, negative, or 0. So when it is positive, when the displacement is positive, and when it is negative, when the displacement is negative, and when it is 0, when the displacement is 0. So if we ask a question here, if we take a circular path, here is the point A, this is the point B. So if a body completes one rotation, then what is the distance and displacement? So suppose this is the radius r. If a body covers a complete one rotation, means it starts from A and reaches to point A, that time its distance is the circumference, which is equal to 2 pi r. In the B part, if we have to find the displacement, so it will be 0. Why it is 0? Because when the body comes back after completing one rotation, its initial and final position is same. Means initially it was at point A and finally at point A. So there is no change in the position. So that's why displacement is 0. In the second question, we can say what will happen when it is half rotation takes place. During that time, what is distance? So distance is equal to pi r, because half of the circumference is equal to pi r. Means it starts from A and reaches to point B. So it covers a half circle. So that's why it is pi r. And displacement is how much? Displacement will be equal to 2r. Why it is 2r? Because displacement is always the shortest path or the path between initial and final position, which is a straight line. So here it is equal to 2r. Now in the question number 1, if we have to find the what is the speed, so what we can say is speed is equal to distance upon time. So here distance is circumference and the time is, and if we have to find the velocity, then it will be 0. Why 0? Because displacement is 0 and time could be anything. So 0 by t is 0. In question 2, if we have to find the speed, so speed is equal to pi r by t and the velocity is equal to 2r by t. By this example, I hope that you understood the concept of distance, displacement, speed and velocity. Now we can move to the average velocity. Average velocity can be defined in two ways. One is with respect to displacement and another is with respect to initial and final velocity. So with respect to displacement, we can say that average velocity is defined as in term of displacement of a body from initial to final position with respect to time, or we can define it as the average of initial velocity and the final velocity. Initial velocity is represented as small u, final velocity is represented as small v. So average velocity is equal to u plus v by 2. This is the definition of average velocity. One thing we can note it down. When a body moves a straight line or a straight path, then speed and velocity both are equal. Means we can use speed or we can use velocity. Now I am giving you few questions that you will practice for better understanding of this topic. These 4 questions you will practice, and one thing always remember, kilometer per hour we need to convert to meter per second, and the conversion formula is 1 kilometer per hour is equal to 5 by 18 meter per second. Suppose you have 18 kilometer per hour. So what you will do? 18 into 5 by 18 meter per second. So it will be equal to 5 meter per second, because we always consider in the SI unit. And comment your answer. And if you face any problem, you will also mention that.